Welcome to Visual Civil. Today we will explore the world of reinforced concrete columns. These essential structural elements play a crucial role in supporting various types of structures like buildings and bridges. In structural system, the term column is associated with members transferring load to the ground, and the term strut is applied to the compression member in any direction such as those in truss. The IS 456-2000 clause 25.1.1 defines the column as a compression member when the effective length exceeds 3 times the least lateral dimension. If the effective length is less than or equal to 3 times the least lateral dimension, then it is termed as pedestal. Generally, columns can be classified based on 3 criteria. First, based on slenderness ratio. Second, based on types of reinforcement. And third, based on the type of loading. So, let us start with the first classification based on slenderness ratio. The slenderness ratio is nothing but a ratio of effective length of column and lateral dimension. Let us try to understand this with an example. Consider a column of width B and depth D. Let LEX and LEY are the effective length of the column in respect of major axis and minor axis respectively. Then the slenderness ratio in respect of major axis is the ratio of LEX and D, and at the slenderness ratio in respect of minor axis is the ratio of LEX and B. So, depending on the slenderness ratio, columns may be classified in 2 categories. First, short columns, and second, slender or long columns. IS 456-2000 clause 25.1.2 classifies a column as short when both the slenderness ratio, that is LEX by D and LEY by B, are less than 12. If any of these ratios is equal to or more than 12, then it is termed as slender or long column in that direction. The above definition is not suitable for non-rectangular or non-circular section, because in these sections the slenderness ratio is better defined in terms of the radius of gyration rather than the actual dimension. Now let us move to the columns based on the type of reinforcement used. Here columns are classified into following 3 groups. First, tied columns. Second, spiral columns, and third, composite columns. In tied columns, the main longitudinal bars are confined within closely spaced lateral ties. In general, tied columns are the most commonly used, having different shapes like square, rectangular, circular, T, L, etc. In spiral columns, main longitudinal reinforcement enclosed within closely spaced and continuously wounded spiral reinforcement. These spiral columns are mostly adopted with circular sections. In composite columns, the longitudinal reinforcement is in the form of structural steel section or pipes with or without longitudinal bars. Now, let us see the column classification based on types of loading. Here, columns may be classified into the following 3 types. First, axially loaded columns. Second, uniaxially loaded column. And third, biaxially loaded column. Let us understand the first type, axially loaded columns. When the gravity load is acting along the longitudinal axis of column without any eccentricity, then column is termed as axially loaded column. This type of columns are relatively rare. Therefore, in practice, the interior column of multi-story buildings like C6 in this plan with symmetrical loads from floor slab from all sides can be a common example of this type. but the clause 25.4 of IS code ensures that all columns should be designed for minimum eccentricity to resist the nominal eccentricities in loading. Now, let us see the second type, uniaxially loaded columns. When the axial load is acting at an eccentricity E from the column center along any one axis only, then it is called as uniaxially loaded columns or axially loaded column with uniaxial moment. Sometimes when a column is subjected to an axial load with a moment about any one axis, that is either major axis or minor axis, then also we can say the column is axially loaded with uniaxial moment. In practice, when the eccentricity of load in column about one axis is negligible, whereas the eccentricity about the other axis is significant, then column can be termed as uniaxially loaded column. This situation is usually encountered in the exterior columns of interior building frame. For example, columns C2, C5, C8 and C10 of the given plan are in the same situation, which can be classified as uniaxially loaded column. If we consider column like C7, the span of connected beam B14 and B15 are same. If we are assume symmetric loading on these beams, then no eccentric loading will be generated on column along grid line CC. But the span of other two beams B5 and B6 are significantly different. If they generate significant eccentric loading along grid line 22, then column C7 can also be termed as uniaxially loaded column. Now let us move to third type, biaxially loaded columns. When a column is subjected to an axial load with a moment about both major axis and minor axis, or load will act at an eccentricity of Ex from major axis and Ey from minor axis, then we can say the column is axially loaded with biaxial moment or biaxially loaded columns. In practice, the columns situated at corners of the building are generally encountered the situation of biaxially loaded column. For example, corner columns C1, C4, C9 and C12 shown in the given plan can be categorized as biaxially loaded columns. Similarly, columns like C3 and C11 can also be considered as biaxially loaded columns if the loading eccentricities along both the axes of the column are significant. That's a wrap on types of column. If you found this video helpful, give us a thumbs up and don't forget to subscribe for more design insight. Drop your queries or experiences with column types in the comments below, and we might feature them in our next video. Until then, keep learning.